You, Patrick. Can everybody hear me okay?
Yeah, we got you.
Okay, to start off, the focus of the New Hampshire DOT project was on communication paths and message processing. However, we did have access to a prototype onboard unit, and we were able to verify our deployments with that onboard unit. For some background information, for our study, we had the listed partners. The project was funded through the New Hampshire DOT utilizing FHWA STIC funding. The City of Dover allowed us to utilize their existing signal infrastructure, including fiber optic interconnected McCain ATC controllers networked to a central system. And we worked with Denso to acquire the roadside units we used in the onboard unit for testing. Additionally, the University of New Hampshire Connectivity Research Center was a research partner, and they provided the computer engineering expertise required for our project. We set the listed objectives for the project. As we had limited funding, our goal was to test something novel rather than focusing on mass deployment. In our discussions with the CRC, we decided to pursue a field evaluation of DSRC technology compared to what is currently possible with cellular communications. We hope to answer some questions surrounding the DSRC versus cellular debate and determine the feasibility of a simple open source cellular option. The following two slides detail the two communication paths that we explored in our study. This first path utilizes DSRC radio technology to communicate between the controller and the onboard unit display. In this configuration, the V2I hub is taking the SPAT and MAP data messages, converting the messages to J2735, and then passing it to the RSU to be broadcast. The Denso RSU also has the capability of converting the messages, and we tested and confirmed the functionality in this RSU. This next slide is the novel part of our project, where it details our communication path utilizing the existing cellular network. The CRC configured a basic SQL server to store the J2735 messages from the VDI hub, and the server could be accessed in the field through a cellular internet connection. We were fortunate that the CRC had the availability and resources to fully bench test both communication paths before deploying in the field. We ran into a number of compatibility issues between the earlier versions of the VDI hub and the Denso RSU, where the Denso RSU had a rather strict definition of how the J2735 messages should be formatted. Once diagnosed in the CRC, we coordinated with Leidos to update the V2I hub and work through the issues we were observing. The lab testing also gave the CRC time to develop and test the cellular communication path in a controlled environment before deploying to the City of Dover's private traffic network. The CRC performed testing in the lab to explore the functionality of the equipment and establish a baseline for what to expect in the field. Based on the average file sizes, the VDI hub is transferring roughly 11 kilobytes per second to the RSU or server. In the RSU configuration, this isn't an issue, as each RSU would be acting independently with its own VDI hub. However, in the cellular server configuration, this could add up to significant continuous network traffic. Once we were complete with the bench testing, we deployed the equipment in Dover and began field testing. Interestingly, we found that the RSU performed better in the field than in the lab environment. This may be due to the poor GPS connection, the CRC, or the DSRC might have been interfering with itself within an enclosed environment. Unfortunately, we didn't have the budget to explore this inconsistency further. We also measured the maximum range that we could receive the SPAT message using our onboard unit and determined that the average maximum range was around 800 feet. We also tested the LTE communication path and found that the latency in the field was also lower than the lab testing. Overall, we were impressed by the performance of the cellular path, as we were expecting much larger latencies over the existing 4G LTE cellular network. So just to quickly wrap up with some of our observations and lessons learned. As previously mentioned, we did run into some compatibility issues between the VDI hub and the RSU. This should be expected as anytime new software is introduced to an environment. There's always going to be issues between how one device looks at a message versus the other. We were able to successfully diagnose all the issues, and the current version of the VDI hub that's available incorporates the updates. We found in the field that the DSRC maximum range was around 800 feet, which may or may not be adequate for all applications. For example, with some additional research that we've done in more rural transit signal priority deployments, we've found that the optimal activation distance for the average intersection is roughly cycle length, which, depending on the timings, could be 2 to 3 times the maximum range of DSRC, depending on the speed. Additionally, if a LTE-based solution is desired, the network bandwidth required to transfer the messages should be considered. Overall, we actually didn't have very many complications with our prototype onboard unit. It used a simple magnetic antenna that went on the top of the car and came in through the sunroof, and it ran quite well. Overall, most of our issues were with the VDI hub, so we were very impressed with DEMSO's onboard unit. We did have the opportunity to test the accuracy of the map files created using the USDOT online tool, and we generally found that the map files were accurate for lane accuracy. We did observe some strange behavior when passing through the center of the intersection, where our onboard unit would place us in either the on-posing through or side street approach, but we believe this was mostly caused by the onboard unit's red light violation evaluation of the map file. In conclusion, we submitted our final report in January of this year, and feel free to contact me if you are interested in reviewing it. As for now, the DSRC radios remain operational in the field, and we are considering future plans on possibly exploring pedestrian-related applications. And then for a little bit of excitement, hopefully it works, but to end off, here's a short video of our DSRC red light violation application in operation at one of the test intersections. And it skipped it. There we go.
For those on the webinar, if the video is a little bit laggy, there's all sorts of factors that I think you guys are well aware of what goes on when you try to stream video online, and depending on what platform you're going through. But you got to appreciate Curtis for bringing that into our presentation. Thank you so much, Curtis.